Okay, we're going to look at a certain notation to discuss a set of numbers. And typically this will be for a set of numbers where there's infinitely many numbers. So we can't list all the numbers. We have to use notation to represent that. For instance, if I wanted to say every number bigger than 5, I can't make a list. That list goes on forever. So I just have to be able to express that in some way. So we're going to talk about that because we're going to use this skill in the next topic in our next class, or maybe in 2 classes, but this is a skill that we need. So if you want to describe all the real numbers x such that x is greater than b, so this is very abstract here, but if you're saying all values bigger than some value b, we can look at a graph by putting b on our number line, and we want to say all values greater than it. So I'd put an open circle at b, and I would color in all the numbers on the number line that are to the right of b because they are bigger than b, and I put an arrow because it goes forever. We're going to use interval notation so that we don't have to give a picture of what I mean. So interval notation can be confusing for students because it can look like a point. So we use these parentheses, okay, and the first number is kind of like where the lowest number or the smallest number or the first number on our interval. And the second number is the last number or the largest number on our interval, okay? So if this goes on forever to the right, numbers larger than b would just keep getting bigger and bigger and bigger, and there is no end in sight. So the way that we say that is we use the infinity symbol. This will make a little more sense maybe if I use a number instead of b. Let's say that we want to say all numbers. I'll do it in a different color so that it stands out different. Let's do it in red. Let's say that we want to do all numbers. We want to say all numbers larger than the number 4. Oh, here we go. My pencil's going to get crazy. All right. All x's that are larger than 4. So all real numbers just means every number. All the decimals, all the fractions, all the irrational numbers, not just like integers. All right, so all numbers larger than 4. The way I could show that on a graph, on a number line, is at the number 4, I put an open circle, and then I would color in all the values bigger than 4. Now, it's not including 4. I do not mean to include 4. So it's all numbers larger than 4. That's why 4 has an open circle, okay? The way we'd write this in interval notation is we would say 4 comma infinity. 4 being the lowest number, and I'm not including it, okay? All the way up to infinity, which is the largest number. It just goes on and on. So what this set of numbers means, when I write 4 comma infinity, I'm saying numbers like 4.01, 5, 7, 22 pi, the square root of 1,000. All of these numbers are larger than 4, and they're in this set. Numbers like 100, 1,000, 1,572, 1,874. Just whatever. Any number larger than 4, okay? And it never ends, so that's why I go to infinity. A couple things to note. An open circle, I'm going to write that up here, open. These things are all the same. When I say less than, that symbol is an open circle on the graph, which means you don't include the value. And these all mean the same thing. And in set notation, it's a parentheses. Or sorry, interval notation, it's a parentheses. Those are all the same thing. These all mean not included. Okay? The next example, we're going to look at what happens if we want to include that value. So now we want to say all real numbers of x such that are greater than or equal to b. So on the graph, I would put my number b. This time I would use a closed, I don't know why my pen's freaking out, I'm sorry. I would use a closed circle to say that I want to include that number in my set. So annoying. And then I'm going to color in all the numbers larger than it. In set notation, sorry, I keep saying set, that's a different notation. In interval notation, we're going to say starting at B, that's the smallest number, and then I'm going to end at infinity. That's my largest number. Notice I used a different parentheses. I used what we would call a bracket. So let's use a more concrete example here. Let's use that 4 again. So if I wanted to say x is all numbers larger than or equal to 4, I could put 4 on my number line. This time I put a closed circle. That means 4 is included in that set. And I'm going to color all the numbers to the right and go on forever. Remember, these are numbers like 5 and 7. Apparently my garage door was open. Somebody's home. Hopefully. All right, so the way I write that out is I want to go start at 4 and end at infinity. All right, notice I put a closed bracket on the 4. That means that 4 is included. So if we want to include an interval notation, it's a bracket. Like that, a square bracket. On the graph, it's a closed circle. And the symbol, I did this in a different order than I did before. I should have kept the order consistent. Sorry. In interval notation, in set notation, it's less than or equal to. And these all mean including. Oh, this pencil's freaking out. So we are including. All right, so that's, again, from my smallest number to my largest number. This means including 4 right here. This means that I'm including 4 in it. This one is not including 4. Infinity just goes on forever. You could never include it. So infinity must always have these rounded parentheses. You never include infinity. All right, moving along here. Let's do all numbers where x is less than a. So on this graph, I would put a, and I would say open circle because we're not including it, and it's all the values less than a. Again, a could be some number like 4 or 5, like I did before. So how would I write this out? Well, this time my smallest number is negative infinity, and my biggest number is a. And I'm not including a. So I do a rounded bracket. Okay? So again, I could never include negative infinity. So when I say all the numbers less than a, the number that's all the way left down here is negative infinity. That's the smallest number. They just kind of keep going and going and going. They keep getting smaller and smaller and smaller, like negative 1,000, negative 1,000,000. All right, so that's how I describe my notation from negative infinity to a. Remember, this does not include a. If I were to give you a more concrete example, I could say x is less than 2. So a graph, I could slap 2 on there. Open circle because I don't want to include 2, and color in everything to the left. That means my smallest number on this interval, the lowest number, the number all the way to the left, and the garage door is closed, would be negative infinity. And the highest number would be 2, and I would not include 2. All right, so now let's go to includes all real numbers x such that x is greater than or equal to a. So now we have greater than or equal to a. So I have some number a, and we're less than or equal to a. So I do a closed circle, and everything less than it, that would be to the left. Remember, the number that's all the way down here to the left is negative infinity. So in interval notation, I start with my smallest number, negative infinity, never include infinity, so always that round parentheses. And then my highest number I stop at is a, and since we want to be equal to a, we want to actually include a, so we're going to do a square bracket. Okay? I'm not going to give you an example. We can kind of see now that a could just be any number that I want. All right? includes all real numbers of x. So every single number is just the entire number line. So it would go from all the way left to all the way right. So the number all the way down here is negative infinity, and the number all the way at the top is positive infinity. So in interval notation, my smallest number is negative infinity. My largest number is positive infinity. You could never include infinity, so it's always the soft brackets. Now I'm saying x is the numbers between a and b. All x is larger than a, but less than b. So I'm going to put a is the smallest one, and then b is larger than it, and x is all the numbers in between. Now I don't want to equal a, and I don't want to equal b, because I don't have an equal symbol over here, right? So it's just all the numbers. X is larger than a, but also less than b. So it's basically the numbers between a and b. So in set notation, this would be a, and I would do a soft, a curved bracket, not the square brackets, because I don't want to include a. And the highest number would be b, because b is the largest number. When I look over here, large is pointing to the right, so b is the largest number. All right? And I don't want to include the b. If I were to give you a more concrete example, I could say something like x is bigger than negative 2, but smaller than positive 3. So I'd put the smaller number negative 2, and then the bigger number 3. I don't want to include them, so they're both open circles, and it's going to be the set of numbers that are all the numbers between negative 2 and 3. These are numbers like 0 and 1 and 2.9998 and all those different decimals and fractions and irrational numbers between these. Square root of 2 is in that set of numbers, things like that. So I would write it like this. The lowest number is negative 2. The highest number is 3. I'm not including either one, so rounded brackets. All right, we're almost done here. Includes all real numbers x such that x is greater than or equal to a and less than b. So now you have to be really careful about your symbols here. I'm going to include a, but not include b. So a is the smallest number because I can see the symbol here, less than. So a is less than x, which is less than b. So a is the smallest number, and b is the largest number. And x are all the values in between, so I color them in. Now at a, we're doing a closed circle because a, it can be equal to a. And at b, we're doing an open circle because it cannot be equal to b. All right, that's how we would graph it. For our notation, we would say starting with the lowest number a, and we would include the a, so we would use square brackets, that means includes, and end at the highest number b, but we don't want to include that, so we would use an open bracket. I'm not going to put in numbers. I think we get the idea. This one is including all numbers x is greater than a and x is less than or equal to b. I'm going to ask you to finish these two, and we'll talk about them to start class. Okay, we'll go over these as a warm-up to start class. You try these on your own. Thanks.